but we were talking about sound waves before. Remember we had the length of a straw? When I had a long straw, was that high pitch or low pitch?
Low.
Low pitch. And when I cut it and it got shorter, what happened? Higher pitch. All right, Mr. Borowicz here is going to talk about sound on stringed instruments. What that was open tubes. What he's going to do is he's going to give you a little lecture about sound on stringed instruments, i.e. his guitar. All right, go right ahead.
Okay, so there's a lot of physics going on when someone plays a guitar, and it's a lot of stuff that you guys have learned and know already. So you learned that longer strings mean lower frequency or lower notes, and you learned that like shorter strings mean higher frequency. Well, there's more stuff that a guitar uses about physics and frequency when you hear pitches on it. But first off, this is an electric guitar, so if I play stuff on it, you don't hear very much at first. I mean, it's like you can kind of hear this, but you don't hear that much. And it's because there's not that big body, you know, like acoustic guitars have that hole cut in the middle of them, and they have this big hollow body. Well, the sound waves go into an acoustic guitar and resonate, constructively interfere with each other, and come out louder. Well, an electric guitar doesn't have that. What it instead has are these guys, these little dots here. You'll notice there's one dot underneath every string. And these little dots here, what happens is when you plug the guitar into an amplifier, which cleverly increases the amplitude or the volume of the wave, it's a clever name it's got, these set up a little magnetic field around the guitar string, and when the guitar string vibrates over them, it detects that magnetic field, plays it out through the amp. So you don't really hear too much. You don't hear that very much, but when I plug it in and turn it on, then you'll hear something, and then I'll irritate the whole school now. So now we hear noises when I play stuff on it, because it's amplified. So it's actually sort of in tune, which is cool. But I'll talk about how these are the three ways that anyone who ever plays guitar is going to use to change the notes that they're playing, and not just be playing like, and that's cool, but that's not really music, right? And you can change the length of the string though, and you can make this note a little more interesting. I can shorten the string by putting my finger somewhere on the guitar fret. So like right now when I hit this note, this is an E flat that's playing right now, the guitar string is vibrating from here to here. So it's about yay long. I don't know, like maybe 2/3 of a meter or so. That's how long it is. And how can I make it shorter? Well, I can put my finger somewhere else, like, I don't know, here. Now the note is higher or lower in frequency? Higher. It's higher. And as I make the string shorter and shorter, the note gets higher and higher and higher. So you can play an open string, that's the lowest note you can get, and then anytime you put your finger on a fret, now the string is vibrating from here to here, it's shorter. When I go up to here, it's vibrating from here to here, shorter and shorter and shorter. So if I shorten the string, I decrease the length, I increase the frequency. Another thing we could do is we could change the thickness of the string that we're playing on. So there's 6 strings on an electric guitar. This one over here is the thinnest one, and then they get increasingly thicker as we go over here, and this one's the thickest one. Does anybody know which one will make the highest frequency? It's the skinniest one. This one makes the highest frequency, the skinny one, and the fat one makes the lowest frequency. And all the ones in the middle, or you can just play them all at once, and you got higher to lower frequencies. So thickness, less thickness means more frequency. So that's another thing. And then the last thing is the tension in the string, which you can also change around. And you see like when people are like really rocking out, maybe they got like the distortion on, and they're like, you gotta get into it too, because it's like cooler that way, like. You can bend the string up, and when you increase the tension in the string, you increase the note too. So I'm playing a note, but if I bend it, I can start to make it sound cooler. Then if I bend it all the way up, that's pretty small. So you want to combine all these things together when you're playing stuff on a guitar, and you can make cooler noises. So like you can combine, let's say, a length switch with a thickness switch. So I can play different strings, that's the thickness, and I can play different lengths. So I can be like, so that's combining length and thickness, I can combine switching the length and the tension and be like, so I bend up, and then I change the thickness of the string. You can play around with that, and you can combine all three of them. You can do tension and thickness, and you can like just go totally crazy. And you can combine all those things together to make different noises. But there's more stuff too. Like, you can't just play any old notes on a guitar, because then it sounds like crap. You got like, if you just start playing, that doesn't sound very good. And if you play some notes together, they sound like terrible if you play them together. Like, these sound okay. Like, that sounds good. That's nice. But if I play these notes together, that sounds awful. Like, terrible. Like, I would be booed off the stage if I tried to play music like that anywhere. So some notes add together really well, some notes don't add together well at all. And you gotta pay attention to that stuff, so you need to pick your notes properly. You need to change these three variables together in a good way that sounds consonant, that sounds nice and pretty, and doesn't sound terrible. So I'll combine all this stuff together and play some blues that sounds okay, hopefully, if I don't screw up too much. Frequencies, right? Yeah. Like, everything has a natural frequency that it likes to vibrate at. Well, sometimes you find when you play guitar, especially if you turn up really loud, that you hit the resonant frequencies of different stuff in the room. Like, there's something in here. Is it the pie pan? I'm making that pie pan over there vibrate because one of the notes that I'm playing in this chord is making it vibrate because it happens to be the same frequency that the pie pan likes to vibrate at. It's its resonant frequency. And like, when I play in my basement, like, I can make there's a drum set in my basement. One of the drums, when I play a certain note, always starts going and fluttering really loud. And I have to like throw like towels on it and like shove a pillow in the thing to make it stop vibrating. And it like vibrates really loud. But you hit resonant frequencies all the time. And that's just a cool demonstration of that. Sorry, this is too much fun. I'll play a little bit of distortion because it makes everyone more angry in the school, and you know, it's cooler because like that's how you gotta rock. With that palm muting, you can do a lot of stuff. And there's other things that guitarists do, like I was doing this in that last song I played, like going. What I do is I like tap the string and then I let go, and like what happens in a string is all these different waves vibrate out in there, and you can touch the string at certain spots. It's called playing a harmonic. You actually touch a node. So like you only let certain notes vibrate out on there, and that's how you do that like cool like. You got it's called a pitch harmonic. It's like that cool metal lick. That's like what I'm doing is I'm hitting the string with my thumb right at the perfect spot to like hit a node on the string and then like make a